Saxon Advanced Mathematics, Lesson 9. Welcome, students, to our 4th week of math. Today's a very exciting day. Today we're going to talk about the idea of congruency, and at long last we're going to talk about proofs. I have been putting off this topic for a year with you because I knew that this lesson was coming. This is a really great lesson that's going to introduce you slowly, gently, comfortably to what proofs are, how they work, and how to do them. The other proof lessons that have preceded this one are way more confusing. So if you've looked in your book at some of those and thought, oh, it chills down my spine, I don't want to do that, don't worry. Today is going to be gentle and kind. Okay, first thing I want to remind you is that the word congruent sounds like a really scary, creepy word. All it means is equal. In geometry, we don't use the word equal because equal relates to numbers. Congruent relates to shapes. The symbol that we use to show that things are congruent is an equal sign with that little thing on top of it, all right, which is kind of fun to draw. So congruent is to shapes as equal is to numbers, all right? So whenever you hear me say congruent, just fill in the blank like an autocorrect in a word processing program. Just fill in the blanks that I'm saying equal. All right, in order to do proofs, we have to understand that there are ways we can prove that triangles are equal. Sometimes you can see it really easily in a picture. Other times you can't, right? Other times the triangle might be spun or flipped over. There's lots of ways that we can change the way the triangles appear, but they still might be congruent underneath it all. So we need some very specific rules that will help us know exactly how to prove that two triangles are equal, even if they don't necessarily look equal. Those rules have a very fancy name. They are called Postulates of Congruency. I hope you feel smart just for hearing me say that. It's a name devised by the ancients using some of their lovely words that have rich and deep mathematical meaning, but are terrifying. So we're going to give them a new name that suits them just as well. Rules for equals. Okay? These 4 rules that I'm going to explain to you in just a minute are the tools we use to prove that certain shapes are congruent, which just means equal. Okay? The shapes that we're going to be looking with are for triangles. Okay? These all relate to triangles. The first rule for equality, or postulate of congruency, we call side, side, side. Okay, the S stands for side. We say this rule as side, side, side. What it means is that if we can prove that two triangles have the same length on all 3 sides, that means they have to be equal. All right? So we can prove that two triangles are equal by using side, side, side. Now, somehow we have to prove that all the sides are the same, but that's a different issue. We'll come to that later. But if we can prove all 3 sides are the same length, then we've proved that the triangles are equal. Another rule is called side, angle, side. If we can prove that two triangles have one pair of matching sides, a second pair of matching sides, and that the angle in between those 2 sides is also equal, they have to go in this order, then we've proved that those 2 triangles are equal. Like I said, once we use these a couple times, you'll understand what they mean much better. The third rule is called angle, angle, side, And it's also sometimes called angle, angle, angle side. Okay? So if we have two triangles and we can prove that they have one matching angle, a second matching angle, and then a side that matches, that will prove that the two triangles are the same, congruent. Now, why are there two here? Because you and I both know that if two angles in a triangle are the same, then all three are the same, because they have to add up to 180, right? So if we can identify two of the angles, then we know we've got three. So some people think that is sufficient just to describe the rule for equality this way. Other people like to write in that third angle. These people say, duh, it's a given. You don't have to write out the third angle if you know two of them match. So that's just kind of a stylistic issue. This one stands for angle, 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 side. Okay, 3 rules of congruency that relate to all triangles. The 4th rule is for right triangles only. And this one is called hypotenuse leg. If we can prove that the hypotenuses of 2 right triangles are the same and one of the legs is the same, then we're good. So this is for right triangles only. And that makes sense because when we talk about hypotenuse and leg, those are words we only use for right triangles. So most students find it fairly easy to remember that this one is for only right triangles and these are for any triangle, because hypotenuse and leg, you have to have a right triangle in order to have those. All right, so these are our 4 rules of equality, our 4 postulates of congruency devised by the ancients many years ago, and we can use them to prove that 2 triangles are equal. Make sure you write these wherever you write your formulas or notes. Make sure you write this, postulates of congruency. I want you to remember that name for these. First of all, so you're educated, and second of all, so you sound smart when you talk about them, right? Because I want other people to know how smart you are. All right, we're ready to start our first proof. And what we're doing here technically are called proof outlines. So we're following the logic of how a proof works, but formal proofs have a very particular and kind of fussy format and way of writing them out. There's lots of little details that we're not going to fuss about right now. We're going to add some of those in later. Right now, we're just going to focus on the thinking process and understand how one approaches and then logics through a proof. So here we go. This is example 9.1. It is our first proof outline, and it's given to, the information provided is very typical and standard. It says, John tells us, given none of this is going to make sense till I draw the picture, so I'm going to do that right now. It's a very cute little picture. So simple. Pretend it's perfect. We have a triangle that's divided down the middle, and it's got letters right there. So let's take a look at what we've got. It says given AD, segment AD, that would be this, is congruent, okay, that just means equal and it's a shape, to BD. Okay, so these two are the same. You wouldn't necessarily know it looking at mine, but that's what it's telling us. And then it says that DC is perpendicular to AB. DC is perpendicular to AB. Okay, that's good to know. The picture looks that way, but that makes it sure. And then John tells us to outline a proof that shows, and so I'm going to abbreviate that by just saying show, that AC is congruent to BC. He wants us to show that that should be the same as that. Okay. Well, we have to figure out what we've got. And so the first thing that we want to do is we want to mark our diagram with what we know. I'm going to use purple. You don't necessarily have to use different colors, although you certainly can if you want. But this is just going to help you follow my logic. We're told that AD is congruent to BD. That means this is the same as that. I like to use the purple because it shows how I know. It's because it's a given. But it's very important that one way or another you mark your diagram to show, yeah, we know those are the same. DC is perpendicular to AB. We talked about that. How do we show it? Oh, well, that means they meet at right angles. So both of those two angles are right angles, right? The other thing that we can mark, it's not specifically told, but this line shows up as the side of this triangle and the side of that triangle, right? Because what we're basically trying to do is say, rather than just look at this big overall triangle, we're dividing it into two little triangles. If we can prove that these two little triangles are the same, then that will prove that these two sides are the same. So that's how we often approach proofs, is that say, let's make little triangles within our shape and try to prove things about the little triangles. John has already drawn the two little triangles for us, but by proving that these two triangles are congruent or equal, then we can say, well, this is the matching side of these two little triangles, so they must be the same. That's our goal. All right, so what we do first is we mark up what we know, and that's what I've done. So now what we can do is call this step number 1. We show what we know, okay? We fix the diagram to add the given information. And so step 1 is to make note of your given information. Step 2 is to show that now we've proven that these two triangles are the same, because look what we've got: side, angle, side. This side, this angle, and this side, we've said are congruent to this side, this angle, and this side. So we know that triangle ADC is congruent to triangle BDC. Remember, we write the letters so that they create the same shape, right? We want them to correspond. We know that that's true, and the reason why is because of side, angle, side. All right? You notice that this is a right triangle, and you might think, hey, why don't we do hypotenuse leg? Well, we don't have information about the hypotenuse, do we? That's what we're trying to prove. We do have information about the leg, but hypotenuse leg won't work in this case because we don't have information about the hypotenuse. We do have a side, an angle, and a side that we proved, because it was told to us, that those are congruent. We know the second side is congruent because it's the same side. We call that the reflexive axiom. We'll get to that. But we have proven that these two little triangles are the same by side, angle, side, one of our rules of congruency. And that's what we're always trying to do. We're trying to use what we have to get to one of those 4 postulates, 4 rules, because once we have that, then we know, okay, we've proved it. The third step is to say, okay, now that we know that these triangles match, we can say that the hypotenuses, the hypotenuse, must be congruent And here comes a cool expression. We say that corresponding parts of congruent triangles are congruent. Let me write that out. Okay? Corresponding parts of congruent triangles are congruent. What that means is that if I've proved that these two triangles are the same, and this is the hypotenuse on each of them, then that must be the same because they're corresponding parts of congruent triangles. So that's how I prove that this side must be equal to that side. And so our final bit of reasoning is right here, and we are done with this proof. We've proved what John wanted us to show, that these two sides are the same. And these are our reasons for doing so. There's a cute little baby proof. We did it. We're done. I hope you see the logic of that. I wish I was with you right now so I could see if your eyeballs were spinning in your head or dripping with reason and understanding. Dripping might not be the right word. Dripping eyes are never a good thing. Unless you're crying, that's fine. Let's do another one. Example 9.2. Okay, there are 3 examples in this lesson and then we're done. All right, let me draw the picture first because I think that makes it more interesting. Here we have a big triangle. And again, what John has done for us is he's divided some smaller triangles within. By the way, John didn't make this stuff up. These are classic proofs that go way, way back to the ancients. So John does not get credit. He's just helping us. He's introducing us to them. Okay, given information is that angle E is congruent to angle H. And again, before I keep going, I'm going to mark that onto my diagram. Angle E is congruent to angle H. Okay, so that means angle E and angle H can be marked with the same tick, right? Because they're the same. And that gives us an angle that is congruent that we can now add to our mental list as we're thinking about side, angle, angle, all that, right? Okay, our next piece of given information is that segment EF is congruent to segment HG. Let's mark that. EF is congruent to HG. Okay, so now we have a side and an angle. This is exciting, right? We're getting closer. Outline a proof that shows that DF is congruent to DG. And I like to mark that in a different color. I don't remember if I did that on the last one. So that I can keep my eyeballs about me. It's easier to see. DF is congruent to DG. Okay, I'll put them in different numbers too, just to make it crystal clear it's different. So we're trying to prove that these sides are the same, and we've got information about these. What that tells me is that let's put our attention onto these two triangles, prove that they're congruent, and then this will be a corresponding side to those two triangles. So I have to figure out what else I can prove about these. So I have to stop and think and look at my diagram and consider what I know about triangles And I'm looking at these two angles and going, okay, this is an isosceles thing, right? If you have an isosceles triangle, there's that relationship, right, between the angle and the opposing side. So if two angles are the same, then that means their opposite sides are the same, right? So I'm gonna mark this, I'll mark it in green. It's not part of my given, it's not what I'm trying to prove, it's what I'm figuring out. This side, I'll use 3, must be this side. So I'm gonna write, step 1 is my given. I mark that information. Step 2, I'm saying that segment ED is the same as segment HD because they're isosceles triangles. Isosceles. And again, if this was a formal proof, we'd have to write this out in more of a fancy way. But I'm just making a note here that the reason I can say that these two sides are equal is because this one corresponds with that angle, this one corresponds with that angle, these two angles are the same, and so the sides have to be the same. Yay! Now, I can say that this triangle, well, let me tell you before I write it down. Now we have side, angle, side, don't we? Side, angle, side. Once we prove that once we prove that the side, angle, side pattern is the same of these two triangles, we've proved that these two triangles have to be congruent. So now I can say triangle, and let's see, I'll do EFD to describe it, is congruent to triangle. Let's see, I went from the outside to the inside and up. HGD. Those two are the same by side, angle, side. That's my postulate of congruency that I've proved. Now that I've proved that these two little triangles are the same, I can see that these orange sides, the ones we're going for, those have to be the same because they're the same part of the triangle, right? So now I can say, I'll write it in the same order that John does. DF segment is congruent to DG segment. No, yes, that's right. Because they're corresponding parts, right? They're mirror image sides of congruent triangles. We've proved that these two are congruent by side, angle, side. So now I can say that these are the same by this rule. CP CTC, I left out one of the C's, all right? And we always write it in that form. That's super classic. And now we're done. Once we get to that stage, we're done. I'll do it here too. Okay? One more. Hang in there, brains. You can do it. Here comes the third example. Here's our picture. We have a triangle. And we have sides that come down like this. That's different. Pretend it's perfect. That's different than what we've seen before, hasn't it? It looks quite a bit different. Let's see what John has to tell us about it. And when I write down my given information, I'm going to write that as step 1 because later that's how we'll want to format it. Okay, given segment AG is congruent to segment EF. Okay, let's mark that. Again, I'm going to use purple to add my given. AG to EF, that's this and this. Those are the same. Okay. What else are we given? CA is congruent to CE. CA, that's the whole That's the whole long strip, right? So this and this are congruent, and I'm marking the whole long side because I can see it's divided up too, and I don't know anything about those smaller bits yet, so I want to make sure that I'm carefully describing the long side of this triangle as what's congruent. Does that make sense? I don't know anything about whether that's equal to that or that's equal to that yet, but I can see it. Oh, I've got two sides. That's exciting. B is the midpoint of segment CA. Okay, let's take a look at that. Segment CA is this whole thing. B is this point right here. B is the midpoint of CA. Okay, the definition of a midpoint is that it's halfway along a segment. So that tells us what we need to know, that this is equal to this. Okay, that's helpful, right? And then we're also told that D is the midpoint of CE. So now we're working on this side. So now we've got the same information that I'm going to use 4 lines here. Okay, and what are we supposed to find or show? We're supposed to show that BG is congruent to DF. Which is BG is congruent to DF. Okay, so what John is saying is we have to pay attention to these two little tiny triangles, show that they are congruent, and then we'll be able to prove the little orange sides. Okay, so we're looking at our purple information and trying to figure out what we can say about this little triangle, the pair of them. I can see right now that we've proved that these two sides are the same, and we've proved that this and this equal that, this and this equal that, and these two are equal. Does that make sense? It's kind of a lot to show, right? But we can make that conclusion that this side is the same as this side because we proved that it's half of this and this is half of this, and these two are the same. So therefore, these two are the same. So we know that segment AB is congruent to segment ED, right? And that's just using our given information. And now here's something else that's really cool that we can get from recognizing that these two are the same. It's that isosceles rule that we used before. If these two are the same, then there must be a relationship between these two angles, right? Because these sides are the same, these angles have to be the same. So I can say that angle let's just say angle A is congruent to angle E, right? That's this one and this one. Those are congruent, again, because of the characteristics of an isosceles triangle. And because we know these sides are the same, we know that these angles are the same. So now let's look at our little triangle. Now we've got side, angle, side. So we can say that triangle, let's do GAB, is congruent to triangle FED. And we know that because of side, angle, side. And I think we've used that same rule for congruency every time in these three examples, haven't we? I believe so. Okay, so we've proved they're congruent. Yay! Now we can say, now it's the home stretch. Once we get to this, it's fairly easy. We can say that segment BG is congruent to segment DF, right? BGDF, because corresponding parts of congruent triangles are also congruent. Yay! I hope these make sense in your brain. Again, here we're not really worried that much about how we're showing our work. We're going to fine tune that as we go. The most important thing is that you're understanding how we can use the information we're given plus a little bit of our own knowledge to build the clues toward one of these postulates of congruency, one of these rules for equality. And then once we prove that two triangles are the same, then we can use this nifty little CPCTC to say, those two parts match, we already proved the triangles match, so therefore the parts must match. Yay, we'll be doing some more, but you guys, we're gonna do nice, cute, simple proofs like this. It's not gonna get a whole lot worse. We're gonna get a little bit cleaner and more uniform in how we show it. But again, I'm much more interested in making sure you understand the thought process than you learning how to write it in a fussy format, all right? So this is gonna sink into your brains for a while. I'm just looking to see what we have in terms of proofs. The way John presents the information in the homework is, let me just show you. It's a little different than what we're doing. What he does is instead of asking you to work the whole proof, is he gives you some different triangles and asks you to choose which congruency postulate, which of the four rules, applies in this situation. So here for A, for example, we look at these two and we say, oh, look, he's got angle, side, angle. Is that one angle, side, angle? No, you look at your list and you go, no, it's not. But you realize, oh, what this one is angle, angle, side, right? They don't have to be in any particular order, but if you have two angles and one side, then that's angle, angle, side. Okay, so that's what you're supposed to be doing here, is looking at the picture, looking at what has been marked as known, and then figuring out which congruency postulate could be used in that situation. Okay, that's all. Goodbye.